All right, everybody, welcome back. Today we're going to work on solving rational equations. So a rational number or rational value is a value that can be written as a fraction. So solving rational equations means we are going to be solving equations where there are fractions. So much like the problem right here. So typically when these problems are as simple as one fraction equals another, they're relatively straightforward. We're going to complete a process we called cross multiplying, where you are going to multiply the values on diagonal with each other and set them equal to each other. So I'm going to have x plus 2 times x minus 3, and then that is going to be equal to my other diagonal, which was 2 times x squared minus 3. Now, the order of these don't matter. I can multiply the x minus 3 first and the x plus 2 second, or vice versa on this side. It really doesn't matter. What matters here is by cross multiplying, we are able to get rid of the fractions, essentially. Now, from here, it's just like solving every other equation. So on my left side, because I have two binomials next to each other, I am going to FOIL them out. So I get x squared minus 3x plus 2x minus 6 is equal to, and then on the right side, I'm going to distribute the 2 in to get 2x squared minus 6. As you can see, I'm going to have a quadratic when I end up solving. So what I want to do is get all values on the same side. So I'm going to simplify my left side. And now I'm moving everything to the same side. So I'm going to subtract my x squared over. I'm going to add x over, and I'm going to add 6 over. This will leave me with 0 on my left side, and then x squared plus x plus 0 actually on my right, excuse me. So I have 0 equals x squared plus x. Again, this is a quadratic, so we can factor or we can use the quadratic formula. Technically, I can try to take the square root but because I've got two values with two different exponents for x, I can't solve using the square root method. So I am going to factor. So when I'm factoring a binomial, or I'm factoring something that has two terms, what I have to do is divide out what they have in common. Both terms, x squared and x, have an x in it, so I divide an x to the front. X squared divided by x leaves me with 1x inside the parenthesis, plus x divided by x is just 1. So these are my two factors. So what I'm going to do is I'm going to then set each one equal to 0, which is our 0 product property. And I'll end up with x equals 0 and x equals negative 1 as my two solutions. So typically with equations, we usually get here and we're like, okay, great, I got my answer, I'm done. What we need to do is make sure both of our answers work. All right, when solving rational equations, we need to check for what we call extraneous solutions. Those are solutions that come up in the solving process that aren't actually going to give us a correct conclusion. So what I'm going to do is I'm going to take my original function. Instead of x, I'm going to plug in each of those values. So first, I'll plug in 0. And I'll end up with negative 3 over 2 equals negative 3 over 2, which is correct. That means 0 checks out and 0 is a solution. Now, I'm going to do the same thing with negative 1. And I will end up with, well, negative 1 squared is 1. 1 minus 3 is going to be a negative 2 over 1 equals negative 4 over 2. And again, those two things are equal. They're both equal to negative 2, so that checks out as well. And my answer is going to be x equals 0 and x equals negative 1. As I mentioned earlier, it's a little bit more simple when we have one fraction equal to another, but they do get a little bit more complicated like this. Now in this case, I've got two different denominators. We can't forget that my denominator on my left side is actually 1. So I can't combine those terms and cross multiply, so I need to make my denominators the same. I need to find the least common denominator. The least common denominator in this case is going to be 1 times x plus 1. So that means I want each of these to have x plus 1 in our denominator. Well, these two already do, so I don't need to do anything to those ones, but this one does not. I need an x plus 1 in my denominator, so I'm going to multiply. Now, since I did it to my denominator, I also need to do it to my numerator. And the reason that is if I divide these two values, anything divided by itself is 1, which means I'm not really changing the original equation. So I'm going to get x plus 1 minus 2x over x plus 1 equals 2 over x plus 1. Now that all of my denominators are the same, they are going to cancel each other out. And that's something that's going to happen in the solving process. If you want to condense and cross multiply, you can see that we'll have an x plus 1 on both sides, so they'll cancel. But the rule is when your denominators are the same, they cancel. In the same way that we would be able to solve this equation here. All right, 2 over 4 equals x over 4. Well, the only way that works is if our numerators are equal because the denominators are already equal to each other. All right, so I can cancel those out and solve. So in this case here, I have x plus 1 minus 2x equals 2. I'll get a negative x plus 1 equals 2, and I can subtract 1 to get negative x equals 1, and then finally divide by negative 1 to get x equals negative 1 is my solution. Now what we need to do is check our work. So I'm going to do this on the side here. My original equation was this. And so I'm just going to plug in negative 1 instead. 1 minus 2 times negative 1 over negative 1 plus 1 equals 2 over negative 1 plus 1. That leaves me with 1 minus negative 2 over 0 equals 2 over 0. The problem is we can't divide a value by 0, so that means that this does not work. And that tells us that x equals negative 1 is extraneous, and therefore we have no solution. All right, now if we had a second solution, we'd plug that in and we'd try as well. But unfortunately, we don't here. So that means the only solution we got from solving didn't work, and therefore there is no solution. So this problem's a little bit more complicated when we don't simply have one fraction equal to another. We've got multiple parts here. The key is to get a common denominator, and that's exactly what we are going to do over here. So same idea as before. We have a little bit more than one fraction on this side, and we do have a fraction on this side. The problem is my denominators, and there's actually a over 1 over here, my denominators are all different, so I need to think about the smallest value that each one of these is going to multiply into. The key here is factoring my denominator in the middle. So I can rewrite this on my left side as 4x plus 1 over x plus 1 equals 12 divided by, well, this is our difference of squares pattern, so it's going to be x plus 1 times x minus 1. And we are going to add it to 3 over 1. The reason we want to do this is I broke up the polynomial that was originally in the denominator here. And I did that, and I ended up seeing, hey, this has an x plus 1 in it, which is my denominator over here. That means that this can multiply into this, and we know 1 can as well. So the way I think about it is to think about that this is our least common denominator. That means this is the denominator that all of my fractions need. Well, if we think about it that way, then this function is only missing my x minus 1, and this one's actually missing both. But if I do something to my denominator, I also need to do it to my numerator. And now all denominators have x minus 1 times x plus 1. So that means that I can cancel them all out, and I'm left with just the numerator, which is x minus 1 times 4x plus 1 is equal to 12 plus 3 times x plus 1 times x minus 1. So I FOIL on my left, I get 4x squared plus x minus 4x minus 1 is equal to 12 plus 3 times, FOIL over here as well, x squared minus 1x plus 1x minus 1. So if I simplify, I have 4x squared minus 3x minus 1 is equal to 12 plus, not x, plus 3 times x squared minus 1. So I can distribute this value in, and I get 3x squared minus 3. And now I can see I've got a quadratic equation here, So I'm going to get all of my values on the same side. I'm going to subtract over my 3x squared. And I will end up with a 1x squared minus 3x minus 1 is equal to 12 minus 3, which is 9. So keep going, subtract the 9 over, and I get x squared minus 3x minus 10 is equal to 0. Now that I've got everything over to one side, I can either use quadratic formula or factoring. If I factor, which I prefer to do when possible, I'm going to start each binomial with x, and then I need two numbers that will multiply to a negative 10 and add to a negative 3. That's going to be a negative 5 and a positive 2. So use our zero product property to set each one of those equal to 0. And I get x equals 5 and x equals negative 2. Those are going to be my solutions. Now, there's a lot of work that we did to get here, but we need to remember we need to check our answer. So I need to plug in 5 first and see if it works. 4 times 5 plus 1 over 5 plus 1 should equal 12 over 5 squared minus 1 plus 3. Now, if I do that, I get 21 over 6 equals 12 over 24 plus 3. And we can check this on a calculator, but what I can also do is make this 24 times 3, which is, let's see, 24 times 2 is 24. It's 48, and give us a 72. So I'll have 21 over 6 equals 72 over 24. 72 plus 12 should give me 84. These two things actually are equal. I can divide both of them by 6. And I will get 21 over 6. So that means that the 5 that I used earlier did in fact work, and 5 is a solution. What I'm going to do is, just to give myself a little bit more room, I'm going to copy this, and I'm going to paste it down here. And now I'm going to try the same thing, but with negative 2. So I will have 4 times a negative 2 plus 1 over negative 2 plus 1. Should equal 12 over negative 2 squared minus 1 plus 3. So I'll get negative 8 plus 1, or negative 7 over negative 1. Should equal 12 over, that's going to give me 4 minus 1, which is 3 plus 3. So negative 7 divided by negative 1 is 7. And then 12 over 3 is 4, plus 3 is 7. And this worked as well. So it tells me that both of these are solutions, and I have my answer. All right, so sometimes when we're solving these equations, we get extraneous solutions, so we need to check both. Sometimes both of them work, just like this example. Sometimes only one of them will work, and that's our only solution. Sometimes none of them work, and our answer is going to be no solution. We really need to plug back in and double check our work. All right, so solving rational equations can be a lot of work sometimes. It's typically easiest when we have one fraction equal to another, just like we did up top in our numerator, and we can just cross multiply. Now, in our bottom examples, when that wasn't the case, What we had to do is get our least common denominator, or the smallest value that each of our denominator multiplied into, in order to simplify. When all of your denominators are the same, you can cross them out and deal with just your numerators, which is what we did in both of these equations to get our answers, okay? Last but not least, after you solve, and sometimes the solving looks different. In a couple of these, in this one, we ended up solving a quadratic. In this one, we ended up solving a linear function. Either way, we're going to solve the equation to get our answer and then plug back in to check our work. Okay? Thank you for listening. If you have any questions or concerns, as always, please feel free to reach out and leave a comment below. Thank you.